We're going. Welcome, everyone. We are just getting started here. The lunar eclipse is already in progress. However, we are dealing with some, well, cloudy issues. We'll be getting actually started in a few moments, so enjoy these animations and getting some information there. And we'll touch base with you in just a few moments.
Good morning, everybody. Welcome to our live stream of the total lunar eclipse from Rancho Mirage, California. Unfortunately, we're dealing with some cloud cover still here in Rancho Mirage, but if that clears out, we'll go live then. And if it doesn't clear out by 3:30, we'll go live by then anyway. So we'll be online pretty soon. Thanks for watching.
Good middle of the night, everyone. We hope you're doing well. This is Eric McLaughlin, the astronomer for the Rancho Mirage Library and Observatory, joined tonight on location, actually, with our observatory coordinator, Lauren Zuckerberg, who is on mic right now as well.
Hello, everyone.
So, special thank you for everyone being here. And again, a special thank you to Lauren for helping to get this all set up. This is quite the setup we have going here. Let's see. Oh, yes, we are here in PDT. So, yeah, we wanted to make sure we've got everyone here. So, yeah, these animations you've been seeing, this one shows PDT and the next one shows UTC for everyone else. We'll come back to this animation in just a minute, but we'll let it actually play before we switch off this view. Because at the moment, we aren't really looking at anything in the sky, sadly, because it is quite cloudy. It is rather unfortunate that that's how things have played out, but nevertheless, we don't control the sky. Yeah, so that is our main timeline right there. You can see, ideally, we want to have a hole in the clouds right around 411 and 420 through 426. For us, the moon will be hitting the mountains around 435, so we will be right in the middle of that whole setup there. We will be actually able to, we will lose sight of it. So anyway, again, there are those UTC times. If you are in another time zone, you can go off of that. That is Universal Coordinated Time. Anyway, yeah, what are we looking at in the sky? Well, let's go ahead and pull this up. Hi, everyone. And from here, we can actually show you our NASA Worldview satellite footage. These are the clouds we've been looking at. This is infrared, so you've got a nice color setup there showing a relative cloud density and location. But yeah, not a good sight. All of Southern California is dealing with it, with the exception of part of LA over here. Even Griffith Observatory is dealing with a bit of cloud cover up where they are. We're hoping this is going to clear up because, yeah, when we looked at the forecast over the past couple weeks, we've had like almost universally great nights. And for the next couple weeks, we can expect probably pretty great nights. Just tonight, it decided to be a problem. So, yes, this is our eclipse live stream, but it is also our, well, how can I say this? Our frustrated astronomers live stream. So, as you can see directly below me, we have our main telescope set up and ready to view. It's not currently able to see anything. This is what it's currently looking at. Likewise, we got a smaller telescope set up just to my left that would give us full disk views. This is its current view. But in any case, we can, using some nice technology, simulate a few things. Again, before I do though, let's give you guys a quick view. This is our timeline that we're looking at here. We've already passed the deep penumbral part of the eclipse, and we are into the partial section of the eclipse. We are currently hanging out right over in this area here, as 320 has passed recently. Yeah, exactly. We got our fingers crossed, and we're hoping it's going to clear up for at least a little bit for right around these times. So hopefully we'll get that view. But what are we actually looking at? Well, in order to not lose sight of things, we set up this view here, which shows over here we'd actually have our main the CDK 700, our big telescope looking up there, the small telescope there, and down here is our all-sky camera view. And as you can see, that is painfully opaque. That is a live view. And in theory, let's see if this works for us. This is what we've been watching all night here. We've had a little spots where the moon poked through. As you could see, it was on up here. Oops, that is actually in front of my pointer. That does not help. Move that down there. Now the pointer should work. So yeah, there's the moon actually visible for a bit, but it is actually, yeah, if I could play this faster, I would, but a nice way of visualizing at least part of this. There were some gaps in the clouds earlier, which got our telescopes all nice and aligned, so we should be doing well there. Hi, Judith. Thank you for joining us. We're hoping we're going to get somewhere with this setup tonight. For those of you in various parts of the United States, let me go ahead and pull up this map here. This map shows globally where this eclipse is visible, and by that I mean if you are inside the red arch, you're able to see the start of the penumbral. If you're inside the orange line there, you can see part of the partial. If you are inside the, or I should say to the left of, so again, on this side, if you're on this side of the line here, you're able to see the partial. If you are to the left of here, you can see the partial. Likewise, the yellow and green lines are totality. So for highlighting that for the US, we've got this image here. And so in theory, this space here will allow us to see, or this is the area that in theory should be able to see totality. Unfortunately, this does not include weather. And it also does not include topography. Yes, we will catch totality being as we are in, we are right down here, but because of the actual topography near the observatory, we will again lose sight of the moon just after totality. So again, that is a good map of what we're looking at there. And once again, there is our whole global view of all of that. Now, again, as mentioned, everything is underway. So if we switch back over to this view, we can hope that that cloud cover will go away. But in the meantime, we will just have to deal with waiting for it by looking at virtual skies like this one. This is what we were hoping to see, as this is our Stellarium view. Stellarium is a great planetarium software, and as you can see from the observatory, it's a little bit of a fine line. Right along there is our mountaintops, and if I switch our grid from azimuthal, which again gives a nice dome shape over us with the zenith being the point there, the point directly overhead, if we switch that grid over to an equatorial grid, we can actually see how everything's moving, because this grid is aligned with the North Celestial Pole. Everything is rotating around that point there. You can see that little white dot there is Polaris. So what that means is when we're looking over near the moon will move parallel to these lines here. So what we are expecting is for it to actually skirt right along down this line here and set right in the saddle point between these two hills here. But if we actually zoom in on the moon, Stellarium does simulate the eclipse, and so this is where we are currently at. And if we're looking at that, it has some interesting stuff going on there. So let's go ahead and switch to some other things to highlight what we're seeing there. We actually already got sunset on a, or rather, eclipse is in totality for a specific place on the moon. Now, this setup here is, if you've been to our Swoon at the Moon live streams or in person, you might have seen this diagram. This is really great for showing a few different things, including right up here. This is a diagram of the moon's orbit right now. You can actually see, based on this, that the moon is at the closest point in this band here. This colored band shows the full range of the moon's orbit. This means the moon is at perigee, which is also visible in the overall diagram that goes behind this. This line that stretches behind the moon is to scale, so that is the Earth there. And way off on this side, we actually have a nice view of the moon located at 28 Earth diameters out on one side, as shown here, 28 Earth diameters away from the Earth, and so it is right at its perigee. And so that is a great place for viewing, again, if it's not cloudy. But this view also allows us to explore the surface of the moon nicely, and we can see some nice highlights right in the center here. We can see the Sea of Tranquility with Apollo 11's landing site down on the southwest edge of it. And with that view, if we hop back over to Stellarium, we can see that, yes, the Sea of Tranquility has, in fact, passed into shadow, as it were. And Stellarium is great for viewing things from the Earth or from a given set of objects. If you want to fly around and explore things, we got another software called Space Engine that allows us to see that as well. And so this is our view from Space Engine, which is, again, lined up with right now. And as such, you can see the moon is quickly passing into shadow here. What is really fun about Space Engine, though, is since we can actually go in and fly down here, we can actually even go ahead and find ourselves Apollo. There's the lunar module. Again, while it can find it, it is not exactly as it looks now, because Space Engine decided, well, we can have a nice, good setup, but why not just leave the ascent module on the lunar module itself? So it doesn't quite look as it actually does, and actually it's probably going to be pretty darn dark when we get there in any case. Let's get there faster. I'm impatient right now, mostly because the sky is cloudy. So this nice black screen shows one thing, but let's go ahead and actually try to look around here, see if it will cooperate, and let me see some things. We might be actually locked onto target here. Let's see. Oh, easiest way to fix this. Let's go ahead and find Earth. There it is. Hit that button. We don't want to go to, but we want to track. This is one of the fun things about Space Engine. This is the simulated view from roughly where Apollo 11 is, looking back at the Earth. I don't have many things on my bucket list, but most of them are completely unobtainable and astronomy related, one of which would be to actually view a lunar eclipse as we're seeing now, except being on the moon for it. So from this view, we can actually go ahead and zoom in and see that from the Apollo 11 landing site, the sun is completely hidden. That is because that spot is in what's called the umbra of the Earth's shadow. Shadows themselves have a specific shape to them, and if you have an extended light source, you can end up with the two parts of a shadow, the umbra and the penumbra. I'm gonna mostly just talk my way through it, but nevertheless, we can actually draw some diagrams. If you find that helpful, just let me know. So for that extended light source, you've probably seen this combination of umbra and penumbra, and you can see it really readily by actually just using two light sources. Why? Because, well, if you have two light sources, you will often see two shadows of an object going in different directions. Where you see a shadow from one light, that area is going to be darker than the surrounding area, and likewise the opposite. But where you see both shadows of those two lights overlap, from that spot, you would not be able to see either of those lights. And again, as a literal talking over things, I am basically hand waving this, but I can demonstrate this a bit differently by drawing some pretty pictures here. And in order to draw this without losing some important information, what I want to do is first switch our view back over to our combo view here. Now, before I go too much into that, so I would like to ensure we can see a bit more, let's do stellarium. That gives us our simulated moon view if we are on target. There we are. Lock that onto the moon there. So now we can actually see the moon while I'm talking and drawing. Okay, so umbra and penumbra. You can think of the umbra of something as you can think of it in multiple different ways, but it's really easy to think of it using multiple light sources rather than talking in the more complicated sense of an extended light source. So say you've got an object here, it's all nice and everything. Let's make it a nice blue object. There we go. And then let's go ahead and have ourselves two light sources. Let's put one, let's see, way out here, like that. Except that one I want to be yellow. There we go. And we'll put another one way down here. We'll actually put it way down here, right about there. Cool. And from those two little point sources of light, we can actually envision how everything overlaps. For example, if you are wondering where the shadow from this light source is behind this, well, you can actually draw a couple of lines extending out from it, like so. There. And let's actually not stretch that out. Excuse me. Let's actually reset that because I want to make sure it cooperates properly. All right, here's our point source light. It will, all of the area that will be highlighted here will be inside that object. Just a moment to fully draw this out. I'm gonna make a big fuzzy image here. So bear with me while I actually draw this. Okay, so let's see. Should be roughly from here. Oh, I missed. Why did I have to try and draw it this way? No! Okay. Fine, I'll draw it the easy way. No, that's wrong. Get that out of here. Okay, so I'll just draw it the simple way that won't involve showing you all kinds of fancy shading. So yeah, got one line, view line there. So if you are standing somewhere along this line right here, that light will cast or will be just on the edge of this object as you're looking past it. And likewise, if we do it again, imagine this yellow dot is a point source, not a resolved source. We'll have another line over here, like so. And thus, if you are in this space, you would not be able to see this light up here. This is the shadow of this blue object here for this light, the shadow from that light. Likewise, over here, we can actually have something similar be cast up yonder. And there we go. And from this one, we get another shadow cast, or another shadow line. The edge of the shadow on this side would be here. And that setup there is roughly what you would expect for all of your shadow lines. So again, if you are anywhere in this section here, you are in the shadow of this object as it pertains to this light source. If you are here, you cannot see this light. If you are here, you cannot see this light. If you're down here, you cannot see this light. If you are here, you cannot see this light. Thus, if you are right here, you cannot see either of these lights. And so you see the shadow cast by both of them in this section here, this little conical section behind this pale blue dot. Now, what does that mean? Well, the sun isn't a set of two lights. Instead, it is actually a nice big single light source, and we can actually think about the edges of the sun as two separate light sources that give us this setup here. And so right in this area here, you could not see the sun. If you are up here, you would not be able to see this edge down here. But if you were in this section, you would not be able to see that edge. And so again, going back to the space engine view, if we actually go and find an area where we can see only part of the sun, we will be in one of these two areas, but not here. the view we currently have is here. So let's go ahead and explore our way to an area in the penumbra. Now, in theory, I should be zooming out. We are a little bit close to the moon there. There it is. It is nice and dark from this perspective. Let's see. There's a section in the penumbra. We went a little bit off there. So yeah, this area here will be in the penumbra. So if we're down somewhere on this part of the moon and look back at the Earth, we will see part of the sun poking out from the side. And so that is what it is to be in the penumbra. So from this perspective, we are in roughly a place like this, where we can only, again, looking down, I actually use this pointer here. So yeah, we are currently looking from a place like this, where this edge of the sun we can't see, but we can see this edge of the sun. That is why we have part of the sun visible there. That is what it means to be in the penumbra of an extended light source's shadow. You have part of that light source covered. Probably saying this in the most complicated way possible, but anyway, I hope people are finding it useful. And again, when you can't see any of this extended object, you would be in the umbra, which is this conical region here. The moon is going to enter that, but only slightly. Again, our view here is this one. I'm just going to go ahead and show this circle here represents a cross-section of this conical region here, while this circle here would be a cross-section of the opposite-shaped cone that goes from this line to that line there. So again, that is what we're looking at down here. And so since this is a conical region, the moon is going to be passing just barely within those limits there. All right, so we're going to just slide that off our screen here and get that mess out of here. Okay. All right. As we can see again, right over yonder, we're still dealing with clouds. This is again a live image from our all-sky camera, so we are not getting all sorts of things we want to be seeing right at the moment there, but we are doing the best we can. So what is actually going on in the sky right now? Well, again, Stellarium gives us the best simulated view of that. This is it here, and we can go ahead and zoom in even more and show just what is outside the field of view. Oh, excuse me. This area here is our last C that is outside the shadow of the Earth. And so which C is that? Well, we can again go back over here, and it's a little bit small in that view, so let's hit this button. That is Mare Crisium. That one right up here. That is just about that is the only C left outside of the umbra at the moment. Again, for context, there's the whole moon, and we again are looking currently this region up here. Is the image from the PlaneWave CDK a live image? Yes, it is. Unfortunately, this is it. We are dealing with a lot of clouds right now. So we do have this image visible in this view. Unfortunately, it's this region of this view right here. So we are hoping that some of these clouds will break a little bit. The fact that there are these weird little markers over here, that might be a good sign. I don't know. Let me actually take a look up there. Yeah, we'll find out in a minute. I'm going to go take a closer look at the sky, so I'll be here, but it will be a little bit. Again, we can see the CDK right here. Looking out, it's already starting to get a little low. So hopefully we get something clear before it gets too low for that guy. Yeah, we're looking at an altitude of 17 degrees. Again, in astronomy, we refer to altitude and azimuth for where you're looking in the sky, where altitude is the angle between the horizon and zenith, and azimuth is basically your compass heading. So when the moon gets below 15 degrees altitude, the CDK will actually not be able to view quite readily. So hopefully we can get a view quickly there. Let's see. Yeah, so let's get Stellarium back on here. So we are actually watching how it's progressing, even though I can't see it. Anyway, I will be back shortly, and hopefully we'll see something pop up on this screen. So if you need a reminder of our specific times that landmark times that we're dealing with, I will show you some right here, right behind where my face was. So I'll be back shortly. All right, so we're still waiting for some kind of clearing in the clouds. It's probably not going to come for us, sadly, but doesn't mean we can't know what's going on. So if you happen to be somewhere that's nice and clear and able to look up at the sky, hopefully you get a chance to do that. But again, as we've got right over here, this is our stellarium view. It's a simulated view, of course, and we can see that there's just a little bit of the moon still in the penumbra. And that is actually enough of the moon in the penumbra to actually make it harder to see all of the moon in the umbra, and also the redness that would normally be associated with that region. Fun fact, when looking at the moon and any object up in any extended object up in the sky, often astronomers will talk about limbs, and in this particular case, we are again oriented one way with straight up over us towards the top of this image, but we can actually take stellarium and change that orientation with a nice little hotkey that will orient us to the ecliptic grid, such that north is now towards the top of the image. And so what we'd be referring to as limbs, often we refer to as the east limb, the west limb. In this case, the north limb of the moon would be actually what is outside of the umbra. What's funny, though, is prior to space exploration, the unreachability of, and by space exploration, I mean actually people going into space, the unreachability of places like the moon had led people to refer to, again, when looking at the moon, this is north for us, this is south for us. Over here, this would actually be towards the western horizon, and this side towards the eastern horizon. So we would often refer to this as the western limb. Unfortunately, that causes all kinds of problems if you actually then go to that object and you land, and the western limb is to the east from you. And so had a lot of interesting things in the Apollo era, readjusting how we refer to things on the moon. However, for places where we can't actually land, like the sun, we would still refer to that side over there as the western limb and this side as the eastern limb, because you aren't going to actually go and navigate on the surface of the sun because, well, it's not actually a surface you can land on. Anyway, just a fun little note there. And now, while all this is going on, you may have seen me messing around in Space Engine. I went ahead and took our camera and parked it somewhere just behind that area there and pointed it back towards the Earth, which gave us this sort of Earthrise type view where we can see just a little bit of light still falling on the moon there. And again, looking at the Earth itself, we can actually see we are about to lose the sun there in its entirety. Now, you might have heard total lunar eclipses referred to as blood moons, and that is a wonderfully interesting subject as to why it would be referred to as such, and we can actually see why it would be when looking at space engine simulation. Now, when the sun goes low on the horizon as viewed from the Earth, we see it turn red, and that is because a lot of blue light is being filtered out. As light interacts with the atmosphere of the Earth, the different wavelengths of light interact in different ways. And in fact, nitrogen and the other stuff in the atmosphere has a tendency to scatter blue light more favorably than red. And so you end up with a red sun at sunrise and sunset, and you end up with nice blue skies during the day. All those blue skies is that blue light, sunlight, being scattered by the atmosphere. Why am I bringing all that up? Well, that red light that's not being scattered, as our simulated view from the moon shows, we can actually even zoom way in here. In theory, is it going to update? What's happening? Uh-oh. Don't like seeing, there it is. Okay. All sorts of concerning things. You can actually see right on the edge of this view here, a bit of red in the atmosphere. Why is that there? Well, that is because it is, again, the light being refracted around there, casting that red light actually to the Earth, the moon rather. And so when you see a blood moon, it is literally the projection of all of the sunrises and sunsets across the entire globe being projected onto the moon. It is a phenomenal concept, and again, I would love to actually see literally every sunrise and sunset on the Earth simultaneously, but we'll see. I don't have high hopes that I'll get to visit the moon someday, but you never know. And so we are just nearing the edge of losing the view of the sun from our simulated spot here over the moon. But yeah, we are just about there. Totality should be coming in the next couple minutes. And in case you're wondering, oh, let's swap back over here. Yeah, there's our sky. Our sky is still not good at all. We got maybe a little bit of something way off to the west, but the moon's not over there. The moon is like over here-ish in the perspective, so not really helping us out. All right, so what are we looking at in our sky? Here's our simulated view from the observatory. If we had a clear sky, we are just about to lose the last shreds of the penumbra, and so hopefully we get to see something nice happen there. We can go ahead and convert back to our local orientation. That is, again, looking as it would be from with straight up in this image being what you would see if you're standing here at the observatory on a clear night. Let's see. Go ahead and zoom in on that there. Now, Stellarium right now is not tracking the moon, so you can actually see when we're zoomed in this far just how fast the moon is moving across the sky. So let's pull that right around there. It seems like the moon is not moving fast in general, but when you actually try and put a telescope on the moon, you become readily aware of how fast the moon is moving across the sky if you don't have tracking on. But it's not so much the moon is moving across the sky as the telescope is remaining fixed in the orientation of the Earth, which is spinning. Again, it's our perspective on the sky that is shifting mostly. The moon does move with respect to the background sky, but again, as shown in the Stellarium view, these lines are attached to the background sky, and you can see the moon is not moving much with respect to them. It is actually the everything in the sky that is moving, rather. Anyway. Yeah. And we are essentially there. This is basically being in totality. And so, swapping back over to Space Engine for a second. Look at our nice view from the moon, our fake view from the moon. Yep. And go ahead and zoom back in. There it's going. We still have a little bit of the sun visible from here, but that's because we're not on the surface of the moon. We can actually fly further down here and get right about there. And from here, we should probably see very little of the sun, if any. Yep, there it goes. So that is our simulated view from the moon entering totality. And likewise, back here at Stellarium, we've got this. And again, everything up in this area here is our actual views of the moon. Sadly, clouds are being a pain in the butt. And if you're still wondering what our weather is actually looking like, it is looking a bit like this. Again, this is infrared view of the clouds. Bluer areas have more clouds. The darker blue, the worse it is. Eventually that turns green, and it also gives some information about the height, the altitude not the astronomical altitude angle above the horizon. No, physical altitude above the surface of the Earth is conveyed partly through those colors. Anyway, back over to our simulated view of totality. You can see Stellarium puts a little bit of a red hue in here. Unfortunately, I can't tell you exactly how much of a red hue there is on the moon because I can't see it. Oh, looks like there's a bit from some images we've seen from other parts of the globe. Yep. All right. Gonna check on something. Enjoy the simulated views at least. I will be right back. Ooh, not what I want to be locked on. There we go. Yeah, I will be right back. Thank you again for your patience while I check on something. Ah, yes, the weather. It is what it is. Unfortunately, we couldn't do anything about that. Thankfully, though, while we are sitting here uh, missing totality, we won't get totality again this year from our point of view, but we will get very near it in November. So, while we may not have a great showing of the moon tonight, maybe we'll have better luck in 6 months. Now, why is it 6 months away? Well, that has to do with the setup of the solar system, in particular, the orbit of the moon and the orbit of the Earth. So, when we're actually looking at the plane of the Earth's orbit, if we look at that plane edge on, it will form a line. And so, if we are to look at that setup, let's see, let's grab one of these and say, pretend that this here is the plane of the Earth's orbit. What color do we want that to be? We'll go with a nice, happy green. All right. And if that's the plane of the Earth's orbit, let's go ahead and throw an Earth on there. Oops, not mean to change the color of that. Oh, well, here we go. There's a nice Earth there. So if that blue line is the plane of the Earth's orbit, let's make another line that will be the plane of the moon's orbit. Now, from our perspective right now, if the sun is right behind the Earth, then the moon's orbit would actually be aligned. And let's see exactly which way would that be. I should be able to figure that out by looking back at this diagram here. So if we're looking at that setup, yeah, that should be going. So if the sun is directly behind here, the moon's orbit is roughly aligned. Again, the angle is way off in this approximation. Don't hold me to that, please. But in any case, it is slanted like so, and it is, so the moon is actually passing directly between the, the Earth is passing directly between the moon and the sun. When we're not at this point here, the sun, well, or rather, when we're not at this point here, the line of the moon's orbit will not pass in a way that lines up the moon with the Earth's shadow. Again, as shown in this image down here, we are just barely getting the moon to pass into the umbra of the Earth's shadow. And so give it a month and the moon won't even pass into this section here, the alignment of it. Again, it's very hard to talk three-dimensional alignments with this setup. But why am I actually trying to draw this in this way when I can just pull up Space Engine again and show you? So let's go ahead and do that real quick. Got a few more minutes left of totality though, so I want to make sure we are actually careful with showing you some at least simulated versions of that. Let's see. Oh, I just realized there's a big line across my face. Let's take care of that. There it goes. Okay. Now, there's a simulated view there. And again, this is our simulated view as seen from the moon. But let's go ahead and zip out of there and we can turn on orbits. Now, all these orbits are all sorts of all over the place. So let's go ahead and fly around and view them from another location. If we actually fly on up here, we can see the yellow orbit here is actually the orbit of the moon, and the green orbit here is the orbit of the Earth. The plane of the moon's orbit and the plane of the Earth's orbit happen to have an intersecting line that is passing. And let's go ahead and actually highlight this a bit better so I can draw on it a bit better with that button. All right, so we have the plane of the Earth's orbit and the plane of the moon's orbit. I need this thing here. And there is an intersection of two planes will always form a straight line. And so if we actually have two planes intersecting like so, there is one line that connects between them. And if I was to draw that line, it is roughly, well, actually, let's go ahead and move around a bit more. Dealing with 3 different programs to try and get this visualization to work. All right, so at the very moment we are at right now, we are still in totality for a couple more minutes. And so the line of intersection between the plane of the moon's orbit and the plane of the Earth's orbit will go roughly from where the moon is now, straight through the Earth and straight on off to the sun. That is the plane of the, or the intersection of those two planes. Outside of this moment, outside of this specific alignment, if the moon happens to be up here when the sun is off over there, the moon will not pass into the shadow of the Earth. That's why 6 months from now, we will get another lunar eclipse. And that is, because if we actually go ahead and, we'll get rid of that line. That line's not useful to us anymore. If we go and look at this from another perspective, zoom way on out, that same line we just drew, if we extended it through the sun over to the other side of the Earth's orbit, over here is around where we will be in November. And again, if you're not seeing that, let me grab a different way of highlighting that. All right, so we are over here in May. If you draw a line through the sun over to here, this is about where we'll be in November. And so that is where we will be in when we have our next lunar eclipse. So again, while we don't have a great view at the moment, again, we can still simulate what we'd be seeing right now. And this is our best simulation of what we are at. We are about to leave totality. And as such, we are going to lose that particular view there. Let's see. Yeah. And so since the majority of that field of view back over on Space Engine, since the majority of the time the moon is not going to be on the line that passes through here, we will spend the majority of the time we get full moons. We do not end up with lunar eclipses because of that tilt in the plane of the moon's orbit. Hopefully that makes sense. All right, let's see if we can visualize it another way. Again, fly on back down to the Earth. In case you didn't believe me that there was a difference between those planes, go ahead and lower ourselves down so we don't zip past the Earth here. All right, and grab onto the Earth if it will let me. Come on, select the Earth. There we go. Now that the Earth is highlighted in red, it'll be easier to tell when looking at it edge on how it varies from other stuff here. Now, of course, the Earth and moon are lost in the glare of the sun here, if I get it positioned well enough. Again, just trying to nudge things around here. But the thing I'm trying to highlight for you right now is very specifically the difference between the red line and the yellow line. So if we're looking here, we can see the plane of the Earth's orbit as viewed edge on makes a nice line that goes through here, and the plane of the moon's orbit is very close to being aligned. I couldn't quite get perfectly aligned. Please give me a break. But yeah, it is at an angle to that. And so that is why we don't end up with a lunar eclipse every month. We actually have to be at a point where the moon will be near the intersection of the of those two planes when it passes behind the Earth. Now, that is actually very similar, in fact, to the scenario we get if we look at things from another perspective. So again, if we're looking at this line, we can actually extend that line back out from the moon through the Earth and straight on over here. If the moon happened to be exactly half an orbit off from where we are right now, we would actually have a solar eclipse going on right now. The shadow of the moon would be falling on the Earth. But we're not having that right now, so, well, there's not a small group of people having a really cool, fun time right now. There's just a lot of people really disappointed in the clouds. Anyway, hope that was a nice little fun bit of geometry while we're waiting for, well, something to happen up in our sky. Really, we're not seeing much. And so if we're looking at that stellarium view, now's the time to actually start getting ready to say, well, we aren't going to see anything. Because as I zoom out here, you'll notice the grid lines are sort of fading away. And that is because the moon is way down in that saddle point between the hills. So unfortunately, we are about to lose any chance of spotting the moon. Nevertheless, we are exiting totality already right now because, again, our time frames for exiting totality can be shown here, and totality ended about 4 minutes ago, or 3 or 4 minutes ago, back at 4:26 local time. Again, that is Pacific Daylight Time, as shown here. All right. So that is the best we've been able to do. Unfortunately, it's all simulated tonight, but nevertheless, we hope you've been enjoying it. We'll go ahead and hang on for a few more minutes. If you guys have any questions, we're happy to address them. And so, yeah, if you guys have any questions right now before we wrap up, we'd be happy to address them. If you want to zip around to any number of places. For example, lunar and solar eclipses don't just happen here, but lunar eclipses, the type of thing we see with the lunar eclipse where the star is completely obscured by the parent body, in this case, the Earth, is much more common than what we typically see on our solar eclipses, where the sun is just barely obscured from the field of view of observers on the ground. It's a lot harder to get a just barely obscured star than it is something that just completely covers it and then some. Again, what we were seeing from our simulated view at the moon is much more common to be seen. But all of that is, of course, rather uncommon because these are all very specific alignments. And when we talk about alignments in astronomy of 3 or more objects, we like to use fancy words, and it's a fun one. It's called a syzygy. Very fun to spell. Let's see if I can remember its spelling. It's SYGYZY. Syzygy is the fancy name for, again, what we're seeing right now in our view here, where 3 objects, as shown here, are actually all in a nice line. Those 3 objects there. But yeah, anyway, all right. There goes the moon, just about to hit that point there. See, just about to hit our local mountain ranges here. Yeah. Lauren just reminded me that we're actually going to get an interesting view from the Earth before too long. Actually, in about 2 weeks, there will be an annular solar eclipse, and I'll wait to talk about the angle of that until we actually lose our view in stellarium here, as it is just touching the mountains now. I poked my head up too high and saw a street light. I was like, what is that? Oh, no, it's not the moon. It was too bright anyway. Anyway, yeah, so again, the orbit of the moon, that is one lunar month, is close to 4 weeks. And as such, 2 weeks from now, the moon will be on the opposite side of its orbit. We will be at a new moon phase, and thus the moon is going to be casting a shadow towards the Earth. It's actually going to line up with the North Pole of the Earth, at least somewhat. And so if you want to venture to the North Pole, you might be able to see an annular eclipse from there. Or you might get terrible weather there too. We'll see. Yep, yeah. So yeah, thank you, Dad. I appreciate that. And yeah, just so you're well aware, that I'm well aware, I've been looking at your wonderful view over in LA. Yes, we can actually see just how clear this area is. So glad you guys have a good view over there. And so even if you're not out, or even if you're out there and you can, whoever's out there looking at the sky, hopefully you can actually get a good view where you are. Glad you have a good view there, Dad. Thank you, Karina. Glad you were here, and look forward to having you again in November. And let's see, Lauren, I'm putting you on. Let's see, trying to remember exactly what time are we talking for that one. That one's closer to midnight, right?
Yeah, that eclipse is at about 1:03 a.m.
Yeah, so
on November 19th.
we won't need to be up quite as late for the next one. So that'll be a fun one.
Yes.
All right. And again, as you can see in our simulated stellarium view over here, this is the end of our view of the lunar eclipse. If you have that view available to you where you happen to be, you might have a much better view of the southwestern horizon than we do. So this is the set of times you want to be looking at right now. We're going to be signing off. But again, if you're enjoying that view, you'll have a lot of cool things to see with that partial set of eclipse, or the rest of the partial eclipse as the moon moves out of that field of view. You've got on into some really nice time frames there. By 6 a.m., yeah, you won't have the partial eclipse. You might be wondering why we didn't start earlier with the penumbral eclipses and such. Well, again, we had clouds, but by the time the moon leaves the umbra, the fade out back to a nice bright moon as it's in the penumbra, it's actually something that's very hard to convey without just comparing two images with the same exposure. You really won't notice it all that much with your eyes. So if you're up for a while now, go up and you can see where you are. Yeah, feel free. Definitely keep an eye on that, because watching the shadow of the Earth move off the moon is something that is a relatively rare sight. And as is the case here, it's made rarer by the weather sometimes. So all that said, we want to give everyone a special thank you. We really appreciate you all being here. We are very happy that you guys were able to join us, and we hope you were able to learn something and get ready for whenever the next nice celestial event gets going. All right, so once again, special thank you to the Rancho Mirage Library and Observatory Foundation. It is through that foundation that we're actually able to offer events like these, and we are more than happy to do so. And again, so special thank you to the Library and Observatory Foundation, and thank you to Lauren Zuckerberg, our library and our observatory program coordinator. So once again, thank you to Lauren. And with that, we are going to go ahead and sign off. Have a wonderful morning, as well as a wonderful time looking up at the sky. Yes, keep on looking up. Good night, everyone.